Hey guys, in this video, we're going to look at the 2022 AP Calculus AB and BC exam, pre-response question number 4. Question number 4 reads, an ice sculpture melts in such a way that it can be modeled as a cone that maintains its conical shape as it decreases in size. The radius of the base of the cone is given by a twice differentiable function r, where r of t is measured in centimeters and t is measured in days. The table above gives selected values of r prime of t, the rate of change of the radius over the time interval 0 less than or equal to t less than or equal to 12. Part A asks us to approximate r double prime of 8.5 using the average rate of change of r prime over the interval 7 less than or equal to t less than or equal to 10. So the computation that leads to your answers and indicate units of measure. Well, r double prime is just a derivative of this r prime of t, and 8.5 is kind of the middle of 7 and 10, so I can say that r double prime of 8.5 is given by r prime of 10 minus r prime of 7 divided by 10 minus 7, and that'll equal to negative 3.8 minus negative 4.4 divided by 10 minus 7. So on the exam, you can kind of stop here. It actually advised that you don't solve it any further than this, because if you were to compute this incorrectly, you actually get points off. But for the sake of the exercise, I'm going to continue. So negative 3.8 minus negative 4.4 is 0.6 divided by 3, which is 0.2. The next thing is that they asked us to indicate the unit of measure. Since r prime of t is centimeters per day and r double prime is a derivative of r prime of t, this will be centimeters per day squared, or centimeter per day per day. Moving on to part B, is there a time t from 0 less than or equal to t less than or equal to 3 for which r prime of t equals to negative 6? Justify your answer. This problem simply tests us to see if you understand the intermediate value theorem. So first we see that r prime of 0 is less than negative 6 and r prime of 3 is greater than negative 6. So negative 6 is between r prime of 0 and r prime of 3. So the first condition is met. The second condition is to show that r prime of t is continuous. Now the problem gives that r is a twice differentiable function. So if r is twice differentiable, that means that r prime is differentiable, which means that r prime is also continuous. So we state that by the intermediate value theorem, there is a time t for t between 0 and 3 such that r prime of t is equal to negative 6. In the next problem, we're to use a right-Riemann sum with 4 subintervals indicated in the table to approximate the value of the integral from 0 to 12 of r prime of t dt. So we're going to first see that this is 3, this is 4, this is 3, and this is 2. So these are the width that we're going to be multiplying with the r prime of t. So integral from 0 to 12 of r prime of t dt can be estimated by, but since we're doing the right Riemann, we're going to start with r prime of 3. So 3 times negative 5.0 plus 4 times negative 4.4 plus 3 times negative 3.8 plus 2 times negative 3.5. Again, in the non-calculated portion of the exam, you're not required to simplify this. It's actually advised that you don't, just because if you were to compute this incorrectly, you'll lose one of the 2 points. But for the sake of the exercise, I'll continue on. This is negative 15 plus negative 17.6 plus negative 11.4 plus negative 7, and the overall sum becomes negative 51. And lastly, the height of the cone decreases at a rate of 2 centimeters per day. At time t equals to 3 days, the radius is 100 centimeters and the height is 50 centimeters. Find the rate of change of the volume of the cone with respect to time in cubic centimeters per day at time t equals to 3 days. So if I kind of simplify the information given, they're saying that dh dt is equal to negative 2. So at time t equals to 3, so t is equal to 3, radius is 100 and height is equal to 50, and they want to find the rate of change of the volume. So they want to find dv dt. So given that v is equal to 1/3 pi r squared h, dv dt is given by 1/3 pi times r squared dh dt plus 2r h dr dt. And if we were to plug in the given information, dv dt is equal to 1/3 pi times r squared, which is 100 squared, times negative 2 plus 2 times 100 times 50 times dr dt. Now dr dt, we go back to the table up here. Since at time t equal to 3, our dr dt is given by negative 5.0. And the unit is in cubic centimeters per day, so I will write that. And again, you don't have to simplify this. And if you do, it actually comes out to negative 70,000 pi over 3 cubic centimeters per day. And all right, that was the 2022 AP Calculus A, B, and BC free response question number 4. Hope you found this video to be helpful. See you in the next video.